Hello everybody, you're watching a different kind of screencast. Today I'm going to be solving codeforces round 747 division 2, but there are two main differences from a regular screencast. First of all, it's not going to be a 2-hour long video. It's just going to be highlights from this contest. So only fun, interesting, exciting parts. And second of all, it's going to be something that I called a challenge screencast, which means that there is a challenge which I need to accomplish during this contest. And the challenge for today is to not use any loops at all in your code. So no for loops, no while loops at all. Of course, pretty much always you can replace your loops with recursion or std generate or something like that, but I will try to avoid this kind of stuff as far as possible. I'm sure it's gonna be an interesting video. Let's go. Okay, the contest starts right now. Let's look at the problems. Okay, so let's go. Oh, I have a loop in my template. That's the first problem of this contest. Okay, I will not be able to use my template. Cool. And second of all, I have no idea how to read all the tests because I can't use a loop. Interesting. Read vector without cycles. C++. Read vector without cycles. Input numbers in a vector. C++ for whoops. Oh my god.
A few moments later.
How to read a vector.
Two hours later.
Okay, I have no idea what to do.
8 hours later.
Okay, there is for each. But it's kind of like a for loop. I don't want to use it.
2,000 years later.
Okay, there is a way to output a vector. That's cool. Copy. Ah, look at that. Oh my god. It's something I need. Okay, so let's read T. And then this kind of thing, right? But it's long. Oh my god, what the hell is that? Okay, I want to believe that it works. And then what I need to do, I can't even solve it with cycles. What? Oh, they may be negative. Okay, so it's just from n minus 1, minus n minus 1 to n. Yes. We need to figure out how to output the list of pairs of these numbers. Oh my god. Okay. There is no map in std, right? Map function in C++, something like that. Map function. No. Std map. No. C++ equivalent of Python map. Yes. Apply. Okay, apply. We need an apply function. So we'll have our input vector and apply. Let's just apply input with we take a long n, and then we do something with it. We return a pair of long of minus n minus 1 and n. What do you think about that? And then we can just probably copy it into the std out. Okay. But the problem is that we can't output pairs. That's the problem. Oh, we can make it not a pair, but a string. What about a string? Yeah. Into string C++ to string. Okay, so we can make it to string of minus n minus 1 plus to string of n. Oh my god, does it work? No, it doesn't. Apply. Is there no such function? Oh my god, it was a question. It was a question. There is no such function. Transform. Right, transform. Transform. Okay, we need transform. Instead of apply, we need transform. Okay, vector strings output of size t, and then we take input and output begin, and we have this lambda function. Let's look at that. Okay. Will it work? Oh, it works. Well, at least it compiles. So let's copy this. Oh my god, it actually works. It's 1 minus 1, 2, 3, 625. Oh my god, it actually works. That's insane, really. Okay, let's submit it. I can't believe that I actually solved the first problem in only 15 minutes. And is it going to work or not? Yes! It worked! Oh my god. I actually solved a problem without any for loops. That's insane. Okay, let's go. Let's go, we can do it. We like sequences of positive integers. Okay. Okay. So we need to take k, make it a binary, and then look at it as an n-based number. Cool. The only problem is that how to freaking do it without any cycles. So let's go. Oh, we also have some tests. So we need to use the previous problem. Okay, we have some tests. We read them. Oh, there are two numbers. There are two numbers. No. Okay, maybe I can read a pair, right? E-stream and operator of a pair of long and long, something like that. And then I can just e-stream in first, second, right? It should work. I'm not sure about that. Pair. Alright. And also I can do the same thing for pairs of output, by the way. O stream, I don't need this. O stream output alright, output first and second. I have no idea what I'm doing. Let's take an input or stream of pairs of wong wong and wong wong. Is it gonna work like that? I have no idea. So, oh no, it doesn't work. Return output. Still doesn't work. And it brings it into this thing. What does it mean? What about this? Oh my god, what am I doing? Template. Type name T? T? Why not? I'm not sure about that. Wait. Template. Type name T. T and T here. What do you mean about that? What do you think about that? Still doesn't work for you. Why? I can read a 2t array of integers, but then how will I split it into 2 parts? That's insane. I didn't think it's gonna be that hard, honestly. Okay, I stream iterator for pairs, C++. Let's see if it's possible. Stream iterator, struct T. Oh, awesome. Awesome, that's awesome. Oh my god, that's awesome. Yes, that's what I need. That's exactly what I need. Okay, I will create my own pair, which will have... Alright, I stream or stream. Is it actually gonna work? I can't believe. Of T. Okay, let's call it my pair actually. T is kind of weird. My pair. Is it actually gonna work? Oh my god, it works. I can't believe that. No? Something went wrong? What went wrong? Constant? Did it actually work? 3, 4, 2, 12. Oh my god. It actually works. Guys, it actually works. Okay, I did it. I did it. Now I can read a vector of pairs without any cycles, right? Right? I read this vector. Now I need to solve the problem. Yeah, we can use transform to solve a problem case by case, right? So now we need wong just const modulo is this number, and our output consists of wongs. Yeah, and we have my pair P, and we return wong. Cool. So now we can unpack our pair and we're gonna have n and k. Oh my god. Okay. Now we only need to solve it for one case. We need to take k as a binary number. Okay, well, I mean, like, I can do something like iterate through all the bits using something, but I don't feel like it's a good idea. Like, it's kind of like a for loop. I don't like it. So how to transform a number into binary C++, right? Is there any good way to do that? No, I don't like that. Decimal to binary transformation. Oh. Look at that. Whoop. Bit set of a constant size. Look at that. Okay, I like that. Binary BK is bit set of size 32 from integer k. And then let's see bk plus equal let's return bk. Alright, let's go. Yeah, it actually works. It seems like it actually works. Okay, oh my god. Now let's use another transformation. Vector of integers. BK string, let's say. And this is BK of size 32. Transform BK string begin, BK string and BK begin. And the lambda is gonna be from a character. We need to output an integer. And it's just gonna be return ch minus 0. So now we have this binary representation. I think we need to reverse bk. Now the last step is to accumulate it into a number. Okay. Zip function in C++, something like that. Boost, no, not boost. std transform. Yeah, let's use this std transform. And also we're gonna have like a vector of integers indices of size 32 and iota ins begin ins and 0. And then we're gonna transform it. We're gonna have vector of pairs of integer and integer bk with ends of size 32. We don't really need a back inserter, but we could have used it always, but whatever. BK begin, BK and ints begin, BK with ints begin. And this function, which takes an integer and another integer, and then it transforms it into pair of integer and integer, which takes like AB. Right? Is it gonna work? I'm not sure. Seems like it's compiling. I don't know. Okay, now it seems kind of easy, right? We need like a bin power function, which I wouldn't say it's a recursion. It's not a loop, right? It's just a function which is recursive, and I'm not replacing some loop with this recursion. It's just a recursive function which takes a pair of integers, and then it returns binary power. Is it gonna work? It should take a long current value, we can just return on current value plus this and then take it modulo. Is this gonna work? Yes, it works. Oh my god, it works. 9, 12. Oh my god, it actually works. And I don't have any for loops, right? Only transform. That's insane. I solved the second problem. Okay, let's submit it. Why is it so hard? I thought it's gonna solve like pretty much all the problems, but it was like 45 minutes and I only solved 2 of them. And let's go. Yes, I solved it. Oh my god. Let's go to the problem C. Maybe, are there any problems with like one integer input? Oh, there is. Oh my god, maybe it's the problem to solve. So fk is 16 for k minus 1 square. 2 to the power of 3, 8 minus 1, yeah. And this we need to multiply by 6. So that's the formula. And we just need our binary power function. And that's it. We don't really need anything else. E1 CPP. Yes, correct. And 3. Yeah, okay, let's submit it. Okay, that was the easiest problem in the contest for me, honestly, because it doesn't need any for loops in its solution. Yeah, that's cool. Hope it can work. Okay, it worked. Fine. But this is something a bit more complicated. Yeah, so let's not go into it, because we need to read something. That's bad. Whatever. Let's go to the first problem. And what about this? I think it's solvable, because you only have tests, but constant input for each test. But let's skip it for a bit. String of characters. Yeah, so basically it's CCC. The answer is 0. If we have a position which index is more than n divided by 2 and that has a C, then the answer is 1. And other, because we can just take this position, and otherwise the answer is 2. I think it should be solvable though. Yeah, I should be able to do it. Let's go to the problem B and copy its solution to the problem C. Yeah, let's make it a different way. In type, which will be like integer n, character strings s. And in type we'll read in n, in C, and in S. And out type is going to be like, we can just, it just can be a vector. And we need this, but for output, or stream, out type, out. And let's return stream. Let's stream outside, out v size, backslash n. Copy our vector into output stream. Oops. Stream. and we need like out v begin, out v end, something like that, right? So we have our integer, yeah, let's say like n is pn, c is pc, s is ps. All right. Something like all function C++. All of. Okay, that's I like that. If all of as begin as end return c equals ch, return out type of just vector of integers, which is empty. Position is find s begin plus n divided by 2, s end ch minus s begin plus n divided by 2, something like that. And if position is equal to n, then something, otherwise something else. Then we need to return out type, which consists of a vector which has just a position plus 1, by the way, and otherwise, so we need like n minus 1 and n. 1 3 2 3 4. Seems like it works, right? 1 3 0. Okay, let's submit it. I mean, like, why not? Seems okay. Is it gonna work? Not sure about that. And yes, it passes. Oh my god, it actually passes. We have 1 hour left and we have 3 problems to solve. Oh my god. The number of imposters. Yeah, I guess it's not a hard problem, but it's pretty much impossible to write it without cycles. That's ridiculous. Let's solve another problem. And special notes cover which already chosen. Let's try and actually do that. The only thing, we can't use cycles, which means that, oh my god, it's gonna be nuts. Alright. And let's call it default answer. Alright. Now we can actually read this vector. Seems nice. We've got this vector of positions. I would rather make it a map, not a vector. Is this possible? Set. Is this possible? So yeah, let's not be that excited. DFS, which takes v and level and returns something. Function of vector of long-longs from long-long and integer. And then we need to like is equal to DFS of 1, and the level is 1. And we need to output accumulate begin and 0% modulus, something like that. Lower bound of v and 0. If LB isn't equal to and LB first and v is equal to isn't equal to v is equal to v. Yeah, let's go. Then we have a child, and we need to go down. Otherwise, we can just return a vector of Wong-Wongs of size 6 and default answer from level. No, it's not a lower bound. I'm false. No, it's not a lower bound. How to check that we have a child in our subtree without cycles? Oh my god. -4, like 3, -3, yeah. And we need VLG, right? I mean, like, probably. Let's return, like, make pair of get first leaf of v color, make get first leaf of v other v. And if we store it in this way, then I want to believe that our lower bound will be in our subtree. Yes. So if we have somebody in our subtree, then let's call it like left LDP is DFS of 2v level +1. RDP is DFS 2v +1 level +1. LB first is equal to v. Need color -1. Need color is equal to LB second. Okay. L0 is LDP 1 plus LDP 2 plus LDP 4 plus LDP 5. Yeah, it should be L0, L1, L2. Right. Now we need to do the same thing for right children. Rights is R0, R1, R2, R3, R4, R5. Lefts need color multiplied by rights. Need color percent modular. Yeah, something like that. And otherwise, ans 0 is L0 multiplied by R0% modular, and so on. 36 is not correct, but yeah. Oh yeah, it's not correct. Yes. My LG vertex v is return 31 minus 30. Wow, 44 minus built-in CLZ LL of v. My LG my LG of LBV is at least my LG of V, and my LG of LBV minus my LG of V is equal to V. Get first leaf of other V. Yeah. Okay. Maybe accumulate doesn't work with the Wong-Wongs. Alright, yeah, seems like that. Okay, the answer isn't correct, but at least it's positive, because it's -1. If level is 1, I guess, then if need color is equal to -1, then we return vector of size 6, otherwise vector on need color is equal to 1. Yeah, let's take it out of here. Default answer is not multiplied by 6, right? Okay, now it works. Oh my god, now it actually works. Let's delete all this stuff. Out. Oof. 4. We don't have any loops, right? We don't have any loops. I suppose so, yeah. I think it's working. I think it's actually working. 0. And this one. Okay, let's submit it. Oh my god, that's insane. So we didn't solve D and we didn't solve F, but we solved E, which is incredible. Yes, it passed. Oh my god. All right. So the contest just ended. I didn't manage to solve any more problems, but it was super fun. And now let's go and see my solutions. First problem was pretty easy, but I would say, but it was hard for me because it was the first time I was doing this without cycles thing. I was googling for how to read a vector for a long time. Good for me that I didn't really need anything like read 2 vectors, because it would be super hard, because in this case I'm reading all the integers to the end of the file. So we read the input file, we have our output file, and I found out that it's possible to just copy a vector into the std out, and then I just use the transformation that takes our input and constructs our output. And it was the first problem. I was trying to figure out what's going on. It was pretty easy, I would say. But the second problem, as you can see, took me like half an hour to solve. And what was my problem? So I needed to read a vector of pairs, which was a really hard problem for me. At the end, I googled that it's possible to do this. You can create your own pair and say that we have operator of reading, and it's not possible to override this operator for just a pair. You need to make a new structure for some reason. Didn't really understand why. And then I was able to read and write pairs. So we read this vector, we have our output, and then I already figured out that you need to use transform if you have multitests, which will transform your input into your output. Then we take our pair, we just simply take mk, do some magic, like I needed to take a number as this binary string and then look at it as a string, as a number in nth base. So I googled this thing which converts a number into a binary string. Then I converted it into an actual integer. I don't know what's that. I just, instead of string of zeros and ones, I then have a vector of zeros and ones. Then I reversed it so that I have a right order of my bits. Then I did a small life hack, like I guess it's fine. I just made a vector of indices, and then I just made like zip function from Python or something. So I constructed a vector which contains a bit and its index, and then I needed to accumulate all the indices. So we need to take, like, we have bit, and if it's 1, then we need to add n to the power of index to the answer. For that reason, I made a function that computes a power, binary power, and then I used accumulate to find this, and then I just output it. It was the first, like, really hard problem, I would say. As you see, I used like half an hour on it. So, and then I solved the problem E1 because I saw that it only has like one number in the input. So it was pretty easy to write a well, this problem didn't need any for loops, so I just was able to solve it because we just need to output like 16 to the power of 2 to the power of -1 multiplied by 6, something like that. And I just use my binary power from previous problem here. Then I went for problem C, which was a really hard problem. Oh no, it's not. Actually, it's not. No, the hard problem is E1. Here I mastered this thing with inputting the custom type. I created my custom type with number, character, and string, and then there was like n times of number, character, and string. I just inputted it and then solved for each test case as previously, and then copied it into the output. Also, I created the output, which is also nice, like outputting the, we have out type, which is vector, output its size, and then we copy it into. So it's actually like copy and there is a copy inside of it. And here I needed to do some operations with strings. I used all of function, which computes if all the characters are equal to ch. Maybe there is an easier way, but whatever. In that case, I just returned the empty vector. Then I found if there is a ch symbol in this string on position starting from n divided by 2, and if there is, then return something, and otherwise return something else. Yeah, and it ended up being not so hard. And then I was solving E2, and as you can see, it's a pretty long solution. Here I also had like an input type, which I kind of made an interesting thing. I converted our string color into an integer color inside our operator so that I don't use all this white, blue, orange thing at all. Also, I then created not a vector of inputs, but a set of inputs. And then I used a really interesting comparator because the problem was I had like a tree and I needed to traverse it, and I had like some vertices of this tree were marked, and I needed to, in a binary tree, I needed to traverse all the vertices that have marked children. And it's actually ended up being a hard thing to do without cycles, because of course you can do something like go from all these marked vertices and mark all its parents and this kind of stuff. But if you don't use any cycles, then it seems like kind of hard. So I ended up with this solution. I made this comparator, which actually will sort our set not in like numbers of vertices, because numbers of vertices like 1, 2, 3, 4, 5. I wanted to sort it in the DFS order, not BFS. And then I would do something else. So this is a really interesting thing that counts, which sorts our vertices in a DFS order. I took a first leaf of a vertex, which is just like add a bunch of zeros to it, and then I sorted vertices in the order of their first leaf, and if it's equal, that it means that it's a child and a parent, and then you need to just compare these vertices numbers. Okay, we have our bin power from a lot of problems actually, our default answer, which is just an answer from E1 problem, and then we have our DFS, which goes through our tree. And I was computing this dynamic programming, which has like 6 states for each vertex, and it combines from the children. And I couldn't really figure out how to do it easily without cycles. Of course, you could do something like e.t.c and that kind of stuff, but it really looked like cycles. Because in the problem B or C, I don't remember where I used e.t.c, it was not really about cycles. It was like zip with indices, so like enumerate in Python and then transform this thing. And it wasn't about cycles, right? But here it would be cycles. So I just decided to write it explicitly. Here I'm checking that we have children in our set of this vertex. Using lower bound because we sorted it in the DFS order. And if we have, then we start from our DFS from our children, and then we're combine their dynamics. And otherwise, if we don't have any children, then we just use a default answer. And then I returned like an answer for our vertex 1, and then I needed to just count the sum of the answers. That's pretty much all. I didn't manage to solve problems D and F. The problem D was really about cycles, I would say. You needed to iterate through all the vertices of a tree, of a graph. I don't really know how to do it like with just DFS and without cycles. It seems kind of hard. Probably it's possible, I don't know. And the problem F was hard. I had like 10 minutes for it at the end of the contest, and I didn't manage to solve it. So, thanks for watching. Have a nice day. Goodbye.